crucial operations for modern cellular system is channel estimation for MIMO. This involves sending known signals from transmitter to receiver and using estimation theory to see the effects of the channel. Once this is known between all antennas, the reliability and the throughput can be greatly improved using linear algebra. Our project was essentially a massive channel estimation effort called Coordinated Multipoint or COM for 5G MIMO.
Current cell phone systems share the wireless channel in time, but in a COM system, everybody can transmit simultaneously. This is done by sending desired data as well as nulling data. But this is only possible if every antenna precisely knows its channel. However, since people tend to move around, the channel is constantly changing. Thus, this is a large estimation operation that needs to be done hundreds of times per second, meaning large amounts of data must move quickly to a back-end server to rapidly perform the channel estimation mathematics. So in our system, the signal arrives at the antennas, it's captured and stored by the FPGA, it's transmitted via RDMA protocol directly into RAM, where the GPU quickly estimates the channels.
Real antenna data is collected from the FPGA base stations and is sent via the antenna emulator we created via a custom FPGA on the ping board, running FreeRTOS. RC applications on the Zinc processor send these test vectors captured from actual antennas to our Linux-based client Proxy station using our own TCP/IP-based socket protocol. This occurs upon command by simply sliding the switch on the ping board to initiate data transfers to the Proxy station.
From this point onward, we have to send the massive amounts of actual captured time sample packets that the Proxy server has received from the antenna emulator. Of course, along with some key calculation parameters that we have to include in the header. This must occur very quickly through the network. To do this, we employ RDMA protocol on a high capacity 100 gig channel. This allows us to bypass the CPU and directly write into memory of the GPU, which greatly improves the latency and performance of the calculations every time we have to do channel estimation.
To perform RDMA, we developed a client and server software applications to communicate continuously with minimal software overhead. The server app is a multi-threaded daemon process that performs the initial RDMA setup, GPU memory registration, and component initialization before accepting client connections. Once a new client is ready, secure RDMA channel connection will be established, and this channel will be used to write the antenna data remotely into the server GPU memory. Upon DMA completion, the GPU kernel will be invoked to perform the channel estimation.
The GPU needs to rapidly estimate the antenna data received from RDMA and provide feedback. The estimation steps on the GPU kernel involves generating the golden sequence, decoding the packet header, and identifying the characteristics of the received data, identify the start offset, phase offset, and the channel prefix, compute and interpolate the channel coefficients, provide the data back to RDMA server, and start with the next packet. The entire operation on the GPU kernel is optimized to happen of the order of microseconds.
So now we will show you the test vectors originating from the FPGA, the proxy server sending them via RDMA directly into the GPU RAM, the GPU server computing the channels, and then finally MATLAB plotting them as they show up.
Welcome to our live demo of 5G comp calibration for massive MIMO. Our server rack above shows we have the proxy server on top and the GPU server just below. The switch positions on the ping board, aka antenna emulator, controls one of two noise variances. LEDs indicate emulated traffic. This bottom terminal is the server app, which we will start now, and you'll see it is waiting for a connection. The top terminal is an RDMA client and proxy server, which we will also start, and you will see it is also waiting for a connection. Now in this terminal, we're going to see that there are no files created yet. Over here in MATLAB, it's showing what the channel estimate should look like, and you can see it isn't showing any channel estimated yet. We'll emulate antenna data by throwing the switch on the antenna emulator card, which would trigger the proxy server to send the antenna data via RDMA. The server showing current throughputs and the number of channels estimated. Then over here on MATLAB, you can see in red the estimated channels are matching the expected channels with a noise variance of 1 added. Now we'll change the switch for noise variance 2 and trigger it again. And you can see the noise spike up over here. And there it is. This is massive channel estimation.
We wanted to do comp for 5G MIMO.
So we needed to do massive channel estimation very quickly.
And we got lots of data from the antennas via the FPGA, and then we send it down the line.
We need to get all this data to GPU quickly. Thus, RDMA protocol was used.
And the GPU needed to do a lot of metrics math very quickly. And as you saw in our demo,
It all worked beautifully.